All right, hello everyone. Today I'll present our CNC gantry project. My name is Vlad.
My name is Mario.
Nick.
For a project specification, it has to travel 12 inches in range. It has to have smooth travel in both directions while supporting 1 kilogram load. It has to be accurate within 5,000 an inch. Has to have minimal backlash under slow and fast speeds. Total cost with the stepper motor has to be under $25. It also has to have clean wiring. For design methodology, the design of the gantry is a gear and a rack, which provides forward and backward motion. It's designed in a way to have bearings on top and the sides, so it doesn't move side to side, and also supported by the bearings on top. Um, and we also used a marked dial instead of stepper motor to see how much it moves.
So for bill of materials, we had a couple components that were 3D printed. The material that the 3D printer used was a PLA, and that is $15 per kilogram. We 3D printed the main box, the shafts, the gear, and the rack. And we also used four 608 double rubber sealed bearings, which is pretty standard in industry, which is why we chose it. Then we also laser cut some of the plywood that they have, which is less than 50 cents. And we also used two quarter-inch screws, and the total cost came out to be $5.20. So for the results, the overall length was 12.6 inches, and the travel length was 9.83 inches. And we found that one rotation equals 2.5 inches.
Now, after performing our testing, our analysis shows that we were fully able to support a 1 kilogram load without any bending or deflection with fully smooth movements. Also, minimal backlash when operating. No binding at high or low speeds. We were able to construct this with a very, very affordable cost. Um, and the design is suitable for stacking into a gantry to have three-axis motion. And the open rail spacing and specialized mounting was used to reduce sensitivity or misalignment. Everything was locked in place so nothing would stray in any direction. And going forward for future recommendations on this kind of project, we recommend adding another rail to improve strength over a longer distance, adding a limit switch so you can't crash into any of the extremes, have a more controlled wire management so nothing gets bunched up, better quality material. Ideally, you wouldn't want to 3D print this or some of the components. We did it for affordability and ease of manufacturing. Using test steppers and encoders for better accuracy, redesigning the main box to hold the load in place and minimize anything sliding around, falling. And overall, since our travel did not meet the required specification, you could still increase the scaling for the entire gantry to allow for the 12-inch travel while remaining under 15 inches of overall length um, in order to, fully meet the scope of the project. This was our project for the CNC gantry in one axis. Thank you for listening and thank you for your time.